Hey everyone, good morning. Thank you for making it out. I'm Wadman, Solutions Architect with AWS Identity, and I have my colleague up here with me, Tatyana Yatskevich, also Solutions Architect with AWS Identity. And of course, we're here today to talk to you about establishing a data perimeter on AWS. So just a question for the room first. Is anyone in here responsible for either building on or securing an AWS organization or a state or multiple organizations? Quick show of hands. All right. A plurality of you in the room, so definitely I found my audience. Thank you so much for joining me here this morning. So I'm pretty excited about this session because data is what differentiates our different businesses, whether that's your customers' personal information, like PII, that you have to protect in order to keep their confidence, data you have to handle in compliance with certain regulatory obligations, your actual business data, and the analytics you derive from that business data. These are all things that are worth protecting. A couple years ago, there was an economist who said, data is the new oil. And when he said that, he meant that it's only as valuable as the value you can derive from it. But I like to complete that metaphor by thinking to myself that oil is pretty fundamentally valuable, and if you have an oil depot or container, you're going to want some fences around it, maybe some barbed wire, chain links, guards, that sort of things, a security program to keep that oil from walking out the door, thus deriving it, thus removing all its value from you. So you might have seen this disclaimer slide really quickly before. They did ask us to put it up there, but I'd like to kind of tack on my own to the back of this. As we get into the back half of this presentation, Tatyana is going to show you real production-grade policies that you can use to build a data perimeter in AWS. And we really think that you should be considering applying these policies and building a data perimeter, but the one thing you should not do is apply them directly in production without testing. Probably nothing good will come from it, if you don't have a really good understanding of what your AWS footprint and estate is like. And now that I've absolved myself of any liability, we can move forward. Please don't test in production. Use your SDLC. Test in non-prod. Please, 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 please. So first, I'm going to start us off with some questions to kind of worry and ruminate about as we work towards the solutions. How do I ensure that only my employees have access to my most important company assets? And if you're like a small company just starting out, startup, medium business, something like that, and you've got like a few sysadmins or security people whose job is managing permissions, this is a relatively simple task for one or a few humans to do at a small enough organizations. Making sure the right people have the right permissions to a given API or in the right Active Directory group. That works really well when you're just starting off. But it really doesn't scale at all as your company gets more employees, more assets, more applications, more SaaSes, more things to manage permissions to. Ultimately, you're going to be doing some level of delegated administrative access to your different applications. And I would say even if you think you aren't doing that today, I would be surprised if there was any one company who had a central security function who was in charge of granting everyone permission to everything. It doesn't seem realistically possible. I can't imagine HR springing for allowing the headcount for that many security professionals. And what's tricky with the delegation is now you're giving some level of judgment to other people and making sure that these other people are always obeying the rules. That takes some trust and takes the creation of some guardrails, and we'll sort of answer that with data perimeters as we go. The next question is, how do I make sure an employee doesn't move important information outside of our corporate environment? Traditional sort of DLPE kind of question, but the complicator I'd like to throw in here is that the definition of our corporate environments are always changing. We have more workforces now going hybrid with employees working from home. Your companies are certainly buying lots of different SaaS or cloud solutions, which are, if you think about it, part of your company's estate. It's part of your environment. It's just sort of hosted outside of what traditionally looks like a network. So this is ever growing. And again, the permissions management and the security team probably isn't going to scale perfectly with this. There will be some level of delegated admins for it, especially those SaaS applications. Like most of the times in my experience, and what we hear from our customers is those are managed from like business unit level, like administrative folks. So now that we've got a couple things to worry about, our agenda, I'm going to talk to you about perimeter security of the past and bring us up towards what is a data perimeter and sort of how they're different from the perimeter security of the past. Then Tatyana is going to dive deep with you into actually how to build a data perimeter on AWS. So if you came up as a sysadmin in the 90s, 2000s, 2010s era, you might have been responsible for a network that looked a little bit like this. In the pre-cloud era, you've got your on-premises, whether that's like a corporate office or data center hosting your production servers, And you've got a DMZ between yourself and the scary things on the internet. Bad actors trying to hack in, malware, viruses, botnets, all that stuff. And your DMZ is built with things like firewalls, DLP appliances, WAF, reverse proxies, forward proxies, lots of different vendor appliance-driven security. And for most of the security threats that were sort of salient in the 90s and 2000s, this was probably okay. I think fundamentally over time, this was found to be untrue as we realized that having a blanket trust of everything inside the green box of things that belong to us probably wasn't right. Like you wouldn't want your desktops to be able to hit the admin ports or the lights out management ports on your servers, so on and so forth. Like the model, it made sense mentally, and keeping people away from, keeping people who we don't expect to be able to access our network from unexpected locations made a lot of sense, and that part of the mental model holds true. But then starting in the late 1990s and really accelerating rapidly to today, the corporate footprint and the things that belong to us started to change. We started to buy software and have other people host it for us rather than buy servers and spend sysadmin time spinning it up ourselves. So many popular applications were outsourced to the cloud. This model became known as software as a service. And whether it was your client relationship management software, some cloud storage, HR software, it could be any one of a number of things. Because this, unless your core competency is developing that software, and most companies are not, it was made a lot of sense to spend money rather than time solving those problems, because most companies like HR software and CRM needs relatively the same, especially with a level of customization that can be applied through those SaaSes on it. But this kind of changed the security model, because if you think about it, we've introduced a second and different sort of security perimeter. So now we have this data, our company assets in the cloud, and we want to make sure that, these assets in this SaaS tenant can't be accessed by, bad actors or from outside our company network. And back in the day, you were pretty lucky early on if the SaaS provider let you set up something like SAML. You were extra doubled lucky if they let you do like an IP allow list, so you could say like only connections from my network are even allowed to my tenant. But especially in the early days, there was a lot of username and password security, like username and password access to these SaaSes. And then things continued to change even more so. So kind of evolving into where we are today. A lot of companies still have a hybrid network footprint or like an on-premises data center. That number is probably dwindling as cloud acceleration adopts. And many companies are still expanding their software as a service footprints. But now these software as a service footprints, they're changing in the sense that it's not just the workforce accessing them. There's also a lot of like B2B, like business to business access happening between SaaS tenants. Whether you're doing like a merger, an acquisition, or just data sharing with a business partner to help meet some business goal, you're now opening additional holes in your cloud platform to let in these different service providers, tenants, or these different companies, and giving them access to your data and vice versa. And this is not just for business to business, this is for like integrations. Say if you had like a data warehouse SaaS platform that held all your corporate data. This data warehouse platform might not have the best analytics or insights capability. So all right, you buy an analytics-driven SaaS and you want to hook that into your data warehouse SaaS so it can get some data to drive some value off of. So those integrations are commonly possible within the cloud. But now we're really changed the perimeter security model of these SaaS-y kind of cloud assets. It started out being maybe a few toggles in a website your admin would log into, but now it's managing different styles of trust relationships, like OAuth credentials grants, like IP addresses from certain users from expected networks. It all gets really, really interesting very fast. And certainly, it's a different world than we used to live in. And of course, the bad actors on the internet, they're still there. They're still waiting for you to misconfigure a cloud asset or leave something exposed that you shouldn't, or for an admin to make a mistake and let them in. So, yikes. I mean, that's, again, kind of focusing more on the worry. And we have a framework for thinking about this and dealing with it holistically within AWS, and we call this data perimeters. Before we dive into that definition, I'd like to talk about the different style of assets in the cloud. So, things that are servers, like those make sense from a traditional network security program. A server has an IP address, you put a firewall in front of it or a firewall on that server, like IP tables or something. You let traffic into certain ports, you let traffic out to certain IPs, so on and so forth. Then you have this class of assets that are really APIs, things like Amazon S3 buckets, Amazon DynamoDB tables, the actual AWS management console itself. These have IP addresses. Yes, literally they're routable over the internet, but it's not like one IP is one S3 bucket. It's an API. All customers hit the same endpoint. So the traditional network appliance or firewall or IP access list style security doesn't apply to these different assets. We need another solution. We need something else. And I would say this isn't, even though we're here to talk about AWS, this situation isn't unique to AWS. You look around different cloud providers for every different type. It's going to be API-driven assets. Very few of them, I doubt, would work exclusively on like a server basis. I probably wouldn't even call it a cloud provider if it was only servers they're leasing to you. So, what is a data perimeter? A data perimeter is a set of permissions guardrails to establish an organizational boundary around your AWS assets using AWS policy. It's taking things that belong to you and using policy to reapply that green trusted box of all my stuff and separating it from the red untrusted box of things that are not mine. This is preventing communication from your AWS assets to AWS assets that do not belong to you. And vice versa, making sure that these untrusted AWS assets that belong to, could be another company, a competitor, certainly a bad actor, from being able to communicate with your assets. Data perimeters are not a replacement for the principle of least privilege. We're going to talk here about applying rules to help safeguard data movement and where data can be accessed from. But it's never a replacement for making sure only the people that need access to sensitive data are the ones that have it. We like to think about data perimeters as like a coarse-grained container around the principle of least privilege, where you apply these rules like, my assets can't be touched by someone else's assets, but you should always be setting and verifying and right-sizing the permissions of all the different principles and IAM roles and users in your AWS organization as time goes on. So, the data perimeter framework we break down into three different sub-perimeters: the identity perimeter, the resource perimeter, and the network perimeter. And each one of these different perimeters has two different control statements we associate with it that we're going to meet with AWS policy. So the first one, only my trusted identities can access my resources. Pretty straightforward. A rule that says if I have an IAM role or user that belongs to me, it can only interact with my buckets, my Dynamo databases, so on and so forth. Only trusted identities can access my network. Actually, putting policy on your AWS networks themselves that say, hey, only my identities can be used from my network. So if someone brought in their own credentials off the internet, bad actor style of scenario, they can't be used from your network. And that protects against threats like unauthorized access by these outsiders, these different entities outside your organization. The resource perimeter. Only my trusted resources can be accessed by my identities. Making sure that your different IAM roles and users can only be used to access your resources. Only trusted resources can be accessed from my networks. Again, applying filters at the network level with AWS policy that says, even from my network, only my different resources can be accessed. The network perimeter. Only expected networks can be used by my identities. Applying policy that say, hey, my different roles and users can only be used from my different AWS networks that I define as trusted, whether that's my different VPC, virtual private cloud IDs, or my different trusted public IP address footprints if I'm operating outside AWS. And lastly, only expected networks can be used to access my resources. Putting putting policy on your resources that govern where they are allowed to be used from. And this helps protect against credential use from outside your corporate environment. So I would say by default in AWS, there is no cross-tenant communication, and these applications only run from the locations where they intend to, or where you intend them to by default, but the data perimeter framework gives you the controls to apply security invariance, which means if someone does something malicious, like intentionally grants cross-account access or intentionally copies credentials outside of your network, this access will be denied regardless of what the bad actor or we'll say unassuming actor, confused person who might be otherwise well-intended but is like taking their corporate laptop home when they're not supposed to, and prevent them from being able to maintain their level of access to your corporate environment. So introducing the policy types before I hand it over to Tatyana. The different policy types that we're going to use to apply data perimeters today. Firstly is the VPC endpoint policy. This is a policy type that controls traffic out from your AWS networks. This is where you make statements like only my identities can be used from my network and only my resources can be reachable from your network. VPC endpoints are technology that allows you to connect to an AWS API from within your VPC without having to do NAT or traverse the internet or have an internet gateway, or essentially enable public routing for a given network in AWS. The next policy type is the resource-based policy. These enforce controls on your resources. These are policies attached to your AWS resources that support policy. Things like KMS keys, S3 buckets, Dynamo databases, so on and so forth. And the fundamental reason that resource policies exist is that they're designed to allow for cross-tenant communication when you want them to. This is a very popular use case. Our customers ask us for, hey, create policies for this so I can say like my partner or my different business units who operate within different AWS accounts can access my resource. But you can also make statements in those policies that say, okay, yes, we'll allow for this sort of collaboration that we expect, but from outside my organization, outside of my trusted IP ranges, this access will not apply. And lastly, the service control policy. These are the policies that enforce different rules on your AWS identities, your different IAM roles, your IAM users, and even the AWS root account users for all the different member accounts within your AWS organization. Service control policies in the data perimeters framework are used to apply statements like only my identities can access my resources, and only my identities can be used from my expected networks, my public IPs, my VPCs. And if either one of those scenarios is not true, the access will be denied. And lastly, before I hand it over, I'd like to introduce the AWS organization. AWS organizations, if you're not using it, which probably everyone should be if you're not, is the AWS service for managing multiple AWS accounts. It's within that you can create different AWS accounts, have some pretty good insular isolation of your different workloads from each other by default, and it's there you use to apply your different service control policies. So definitely consider using AWS organizations if you're not. Each AWS organization, like an AWS account, has an ID, and this ID is actually usable in the different AWS policies to identify the different organizations you want to allow communication from and communication to, and all those policy types I just talked about. And with that, I'm going to hand it over to Tatyana to dive in with you to how to actually go about building a data perimeter on AWS with a sample workload.
Thank you, William. Can you hear me okay? All right, cool. So now that we covered basics of data perimeter objectives and common threats that they're designed to address, I'd like to do a deep dive on the actual data perimeter controls and how they can be applied to a sample workload. And what could be more exciting nowadays than talking about generative AI, right? So we will be using this simplified architecture that depicts two phases of the deep learning: training on the bottom and the inference on the top. So you first feed your model with the curated data set so that it can learn everything it needs about different data types that it will analyze. And then in the inference phase, you will have a human or a machine prompting your Gen AI application, could be chatbot. That prompt with some customized context can be sent to the model, and the response is sent back to the user. So needless to say that when you deploy this application in your production environment, you want to ensure that your data is handled securely across all stages of the AI lifecycle, right? Including data preparation, training, and inferencing. And that is both at the infrastructure operator layer as well as at the developer consumer side of it. With AWS managed infrastructure and services, there are foundational security controls that allow you to achieve that. For instance, Nitro systems that are designed to support large-scale distributed training come with the customized hardware and firmware that provides full isolation of your AI data from the AWS operators. If you use Amazon Bedrock to take advantage of the managed high-performance foundational models, then all the communication to, from, and within your model stays encrypted in transit by default with a minimum of TLS 1.2. So these are just two examples of the AWS built-in controls, but you as the data owner or a security team are also responsible for evaluating and addressing risks from the inputs and outputs of your Gen AI application. And when it comes to selecting the right set of controls, the right place to start is to threat model your workload so that you can identify relevant threat vectors and then select controls for those threats that may lead to business impacting outcomes, right? That's really, for any type of application, not only Gen AI. So in the next few minutes, I want to use this architecture as a reference to analyze common threat vectors that can be addressed by data perimeter controls. And hopefully that will help accelerate your own threat modeling exercise and controls implementation. All right, arguably the most critical element of any Gen AI application is data used to customize your model, right? And this is because you might be fine-tuning your model using highly sensitive business data, like personal data or financial information. In AWS, you can put that training data in Amazon S3 bucket, where a data owner will have to grant access to the identity that is used by your model to train on that data, right? And one of the common security threat vector that you have to consider here is a data owner, as part of that configuration process, granting external access to the data. It could very much be unintentional through the implementation of misconfigured bucket policy. So bucket policy is a resource-based policy that Liam mentioned can be used to grant access to your data, to your resources in AWS, especially useful in cross-account implementations for applications such as Gen AI or data lakes. So the question here is, how do you allow your developers to build and manage this next generation applications while ensuring that no outsider can get access to your most sensitive data? Within Data Perimeter Framework, we have a preventative control that will help ensure that in any circumstances, only trusted identities can access your resources. This control can be enforced using resource-based policies. So resource-based policies not only can be used to grant access, they also can be used to restrict access or put certain controls on external access to your resources. And that control can be written as a single deny statement in the bucket policy. So this is an IAM policy written in JSON, right, which will prevent access to your S3 buckets unless the identity that is making the call belongs to your organization. And your organization in AWS is defined by the ID in AWS Organization Service, that service that allows you to group and manage multiple accounts under your ownership. Right? So by specifying your organization ID in the principal org ID condition key within that policy allows you to differentiate between identities that belong to your organization and those that belong to someone else. And based on that, build the permissions guardrail. So this particular policy statement might work very well for our Gen AI use case, because really the only identity that needs access to that training data is the IAM role, right? Identity that is used by your model. But since data perimeter controls are normally enforced as security invariants across a broad set of resources and accounts, the standard identity perimeter policy accounts for scenarios where AWS services need access to your resources. The most notable example is AWS CloudTrail, the event login service that uses its own identity called service principal to log data, to log your events into your S3 bucket. So with this particular data access pattern, the security consideration that you have to keep in mind is cross-service confused deputy, where you want to ensure that when an AWS service accesses your resource, it can only do it on behalf of you and not someone else. And the source org ID condition key in the second statement of this policy allows you to make that assertion in IAM policy language. So that statement in particular will prevent access by an AWS service unless its request originates from your own organization. So that CloudTrail trail that was configured to store logs in an S3 bucket has to be owned by an account in your organization. All right, moving on to the next threat scenario, where an internal threat actor could configure your model to train on someone else's data. So something that will result in a poisoned output to the users of your Gen AI application and possibly reputational damage to your company. So an internal threat actor configures your model with an external bucket as the source for the training data. Once that external bucket is supplied to the model, it will use its customization role, which was also configured by the threat actor to have all the right permissions to access and train on that external data, right? So how do you ensure that your model can train on your corporate data in an S3 bucket within your organization, but cannot train on some data in an external non-corporate account? Within the data framework, we have a coarse-grained control that allows you to achieve this objective, which is a resource perimeter applied on your identities, ensuring that only trusted resources can be accessed by your identities. That control is enforced using service control policies. We already know that those are organization policies within AWS organizations that allow you to enforce permissions guardrails across all accounts that you own, right? And set the maximum allowed permissions that can be granted to identities within your organization. And since that model customization role is one of the identity within your organization, this service control policy will deny access anytime that role attempts to access an S3 bucket outside of your organization. So here again, you will be using your organization ID as a value for IAM condition key, but this time it will be resource org ID, which will denote the owner of the resource that is being accessed by your identity. So again, SCP can be applied centrally across all accounts in your organization, which means that regardless of the actions and configurations that take place in those individual accounts, it will always be true that your identities can only access trusted resources. All right, moving focus from the training data and onto the actual Gen AI application. That application that will be prompted by your GenAI users can run on a service such as AWS Lambda. So Lambda is serverless that allows you to run your code with the IAM credentials of your choosing. You can attach an IAM role to your Lambda function that will be used to make AWS API calls. But like with any compute, there are like with any compute where developers might have access to the execution environment, there is a risk of that developer, which could be an internal threat actor, bringing their own personal credentials into that environment and using them to move corporate data to a resource in their personal account. Or they can bring some bad data into that environment and pass it to your LLM agent as a context, right, and abuse your model this way. So how do you mitigate this risk? In this particular case, we are trying to reason about what identity is being used to make API calls. And within our corporate network, we want to ensure that that identity can only be one that belongs to our organization. So essentially, we are trying to prevent the presence of non-corporate credentials in our corporate network. And in AWS, there's a very powerful tool that allows you to ensure that, VPC endpoint policies. VPC endpoint policy is applied on all requests that originate from your network and go through VPC endpoints. Liam already mentioned that VPC endpoints allow for private network connectivity from your networks, from your VPCs to AWS service endpoints. And VPC endpoint policies allow you to enforce permissions guardrails on that access. Right, so this is an example of network-centric controls and identity-centric controls working together and augmenting each other. In contrast with traditional on-premises environments where these two types of controls didn't really work very well together. So this is a VPC endpoint policy that will permit access, but only if identity belongs to your organization, again denoted by the principal org ID condition key, or by an identity of an AWS service. Nothing else will be permitted, regardless of the permissions that are granted by other policy types in your environment. So even if that insider was able to bring personal credentials into your compute, they will essentially be rendered useless by this policy. All right, and the last security risk that I want to cover is access to your resources, such as Bedrock model, from the networks that you don't own and don't control. Developers that are managing your models may accidentally leak their credentials into public code repositories, right? Hopefully there are controls in place that prevent the credentials exfiltration. But if that happens for some organization, the risk of someone using those credentials to access their resources is high enough that they implement network perimeter controls in the environment. So those controls would ensure that their corporate credentials can only be used from expected networks. This control is enforced using service control policies again, and a combination of network-related condition keys. So the policy may look like that, which will prevent access unless it is from a network of your public CIDR ranges, or a VPC within your AWS environment. There are a few exceptions for AWS services to be able to access your resources. AWS services will talk from their managed networks, and it is expected. I'm not going to cover the details today, but we will provide some resources for you to learn more about different service access patterns and how to account for them in your data perimeter policy. Another note here is that this policy and some other policies that we looked at today target specific service, Bedrock in this example, They don't have to. You absolutely can expand your data perimeter controls to cover other services, as long as you account for all the intended access patterns in your environment, right? If you need to allow a trusted third-party partner, you need to ensure that you customize your data perimeter policies to permit that access. Alrighty, so we definitely didn't cover all the threat vectors and the data perimeter controls that are designed to address them. But those that we covered, unauthorized access to your resources or unintended data movement outside of your org, are those that apply to any cloud or hybrid environment. And hopefully today we were able to bring some light into how data perimeter access controls could help address them in AWS. And now I would like to hand it back to Liam to share some lessons learned.
Yeah, awesome. Thank you so much. So we're about at the end of our content. I'm going to give you a few calls to action. And the first off was when you're going about thinking to apply data perimeters, make sure you're doing threat modeling and identifying not just what are your high-risk assets, but what are the highest risks? Which one of those control statements is the most meaningful to your organization? What are the how are you going to get the most value out of the human time you spend, crafting and applying and testing these policies? And prioritize the application of the data perimeters based on your risks. I'd lastly really emphasize this. You're not in this alone. Start with our example data perimeter policies. Tatyana, myself, and the rest of our team, we maintain a public GitHub repo with all sorts of long-form literature about our data perimeter policies, but also example policies ourselves. The same ones that you saw mentioned here, but much more verbose write-ups, tons of different examples for different services like S3, KMS, so on and so forth. Lots of literature. And by the way, we accept pull requests. If you raise an issue on that GitHub repo, we will respond. Lastly, apply the data perimeter control statements to all cloud models, to all cloud assets when you're doing your threat modeling. Don't just stop at something on AWS. Data perimeters is the term that we made up after our customer conversations let us actually go create them. But if you think about it, it's really going to apply to any SaaS provider, any large-scale cloud provider. You're going to want to make sure those 6 security objectives are met for your most valuable data. And with that, we're at the end of our content. We have about 10-ish minutes left for Q&A, or until they kick us out of the room, but we can keep it going in the hallway afterwards. So with that, thank you so much. This QR code up here on the screen is going to take you to the data perimeters on AWS landing site, where you'll see lots of examples of our blogs, of our white papers, our webinars, our workshops, our public samples repository, and our success stories. And lastly, I'll give a shout out to a community event, Forward CloudSec. I don't know if anyone here has heard of it or if anyone goes. There have been talks on data perimeters there and lessons learned from customers in the past. And there is some coming up this, I forget the exact date, June something, Chris? June 17th. There is at least one customer there signed up to do a talk about their experience on data perimeters at Forward CloudSec. So check it out. And with that, again, thank you so much for joining. It means the world to us that you're here during the hangover session on this RSA Wednesday. So thank you.